morning, students. In the last class, we discussed about some of the important terms, what they are named as, and what are the prefixes added to that based on the carbon chain, and what are the suffixes added to that if they have the single bond, double bond, and triple bond. Okay. So in the today's class, we are going to discuss about some of the functional group and also the homologous series, and also nomenclature. Okay. So in today's class, we are going to discuss homologous series, okay, functional groups, and nomenclature. Okay. So in today's class, we are going to study these. So I will give some examples, students. Then we will get to know what are homologous series. For example, the first compound is CH4. Okay. The next homologous series compound is CN6. Okay. And third one is C3H8. Okay. Next C2H4 and C2H6 C3 C4 H8, etc. And also next C2H2 C3H4 and C4H6, etc. So students, if you observe, the difference between these two is CH2. So carbon has atomic mass 12, hydrogen has atomic number 1. So atomic mass 1 means total 14 gram or 14 AMU, atomic mass unit. So if we check these two, here also there is a difference of CH2 molecule. Okay. So if you observe these two, it is also CH2. If you observe these two, it is also CH2. Here also same thing. They are differed by how much? CH2. This is homologous series of alkane. This is homologous series of alkene and homologous series of alkane. So in all these things, what you are going to observe here? So each and the next successive terms, okay, the successive terms in the series have the difference of CH2 group. Means the mass difference between them is 14 atomic mass unit. So what are homologous series? Means the series which are different and the compounds which are present in the series are differed by CH2 group. A continuous CH2 group different molecules in the series is called as what? Homologous series. Okay. So if you want to write, the definition is the series differed by CH2 group or are 14 atomic mass unit is called as homologous series. So this is the example. Homologous series of alkanes, alkenes and alkynes. Okay. So this is not homologous series. With respect to functional group, we will study. So as this is the organic compound, students, there may be a chance of, the carbon is there. It is tetravalent. I will take one example here. This is what? Methane. Okay. So one H group may have the capacity to be replaced by any functional group. Or this hydrogen, this hydrogen, this hydrogen. any hydrogen can have the capacity to be replaced by another functional group or another atom. Except hydrogen, if any atom are present, they are said to be one functional group. If so, any functional group are there, remaining valence is satisfied by hydrogen. Understood? If except hydrogen, anything is bonded to this hydrogen and carbon. So you may carbon may be present in this form also. Here there may be a possibility of functional group. Except carbon and except hydrogen, any other extra atoms or heteroatoms are bonded with this carbon, then they are said to be one functional group. So in that functional group, students, for example, if you take OH here hydrogen, hydrogen. Okay. So listen, here how many carbon atoms are there? 2 carbon atoms, that is H. R single bond is A, ethane. But last E is replaced by this functional group, that is OH. This is called as ethanol. So listen, as this is a parent chain, as this is an alkane group, but the name of the compound is finally taken as what? Alcohol. So the functional group is the smallest part of the organic compound which decides the characteristic of the compound. Understood? So here instead of CHOH, if here CHO is there, then it is called as ethanol. Okay? If instead of this here COOH is there, then it is called as ethanoic acid. Understood? So this remains same, parent chain remains same, that is ethane only. So this last Al, oic acid and OL depends upon what? The functional group which is attached to the compound. So here it is a alcoholic compound, it is a aldehyde compound, it is a carboxylic acid compound. So which compound decides the characteristics of the atom here? This functional group. So what is functional group means? It is the smallest portion of the organic compound or a part of the organic compound which decide the characteristics of the organic compound. Understood? So I'll write here. Homologous series, I hope you understand. Homologous series means the series which differ by the CH2. Okay? Alkane, alkene, alkyl is there. Another groups you may take. So if any atoms are there, if they are difference of CH2 group is there, then they are said to be homologous series. Okay? So now we will study about the functional group. Okay, students. So the next one is what? Functional group. So what is functional group? Means the smallest or the small part of the compound which decides or which tells about or decides or which gives specific characteristic to the compound is called as functional group. The part of the compound which gives specific characteristics to the compound, especially organic compound. Okay, called as one functional group. So in this functional group, so many functional groups are there. I'll write and make them and chart, so that will useful for you for the nomenclature of the organic compounds. While you are doing the nomenclature, these functional groups will help to name the compounds. Okay. So first I will keep the list of functional groups here. So start from CH4. Okay. So this is aldehyde group. So suffix for this is right here. This one is functional group, name and suffix. Okay, what's the suffix added to that? CH2 group is there, that is aldehyde group, and the suffix added is EL. Okay, if COOH group is there, that is carboxylic acid, so that is oic acid suffix. Next, C double bond O is there, that is called as ketone, ends with O. OH is there, that is alcohol, ends with OL. Okay, next NH2 is there, amide group, here also ends with amide. Okay, next this may be an R. So this is ester group. Okay, so the name is alkanate. This alkane means R group. CH2 is there, 2 carbon atoms, ethanoate. 3 carbon atoms are there, propanoate. This one represents what? Number of carbon atoms. Okay, next. CH2. This is what? Suffixes, the functional groups which gets suffixes. Okay, another one is there. This one is, that is ester. This is alkoxy. I will take it as oxy. Okay, while naming, I write with the compound, I write this, I use these functional groups and I write the name, then you came to know how to name the compounds. Okay, these are the functional groups which carry suffix. So here, if parent chain is there, if this functional group is there, then these functional groups are taken as what? Suffixes, means parent chain followed by the name of the functional group. So the next one is functional groups, their name and prefix. And they are used as what? Prefix. So here another one need to take, student, that is CN, that is cyano group taken as nitrile. Understand? Next. So functional group is there. If Cl is there, then the name of the compound is, or functional group is chloride. It gets the prefix chlor. Okay. Next, NO2 is there. This is nitro group. So it takes the prefix nitro. Okay. Next, another one is fluorine. That is fluoride. This This one is taken as fluoro. Okay. Next, iodine is there. Iodide taken as iodine. Okay. So nitro group is there, then it is nitro. So these are used as what? Prefixes. Means first the name of the compound. If you want to take students, first prefix. Next, root word. Root word means parent chain, carbonyl length. Okay. Next, suffix. So in this, listen, functional group. This single bond and double bond is also a functional group. If single bond is there, what it is called as? It ends with ANE. Double bond is there, ENE. Triple bond is there, YNE. Remember that thing also. Okay. So prefix, root word, suffix, etc. Understand? So first, if this compound is there, prefix, root word, I get this CH3, CH2, OH. Here this is the function group, this is the function group, this is the root word. Correct? So here, this is the functional group, means whether it shows suffix as well as prefix. Which one it shows? It is in the suffix group. Listen, OH is here, so it follows suffix, not prefix. It is taken as suffix. So first, if you left this prefix means root word followed by suffix. Correct? So here CH3, CH2 means 2 carbon atom. 2 carbon atom means ethane. Okay? This last E is replaced by what? This OH. What is that? OH takes the suffix OF, that is ethanol. Understand? Similarly, you take this CH3, CH2, NO2. This R group remains same. Here the functional group is NO2. Okay? If NO2 is the functional group, whether it takes suffix or prefix, it takes prefix. Okay? So that means first it takes prefix means prefix followed by root word. This is not possible. Okay? So you consider this prefix for this is nitro. So it is with the 2 carbon atom means ethane. Nitroethane is the name of the compound. This is the way to write the name of the compounds. Okay? I'll write by using these compounds. I'll write some of the name. You came to understand. You remember this chart, students. This is very, very important. Okay? So the next one is nomenclature, students. This nomenclature of these organic compounds is done by IUPAC name or explained by IUPAC name. What is this IUPAC name? International Unit for or Union of Pure and Applied Chemistry. International Unit for Pure and Applied Chemistry is called as IUPAC name. So all over the world, each and every any, you don't know the language France, you don't know the language China, language of China, correct? But if you use this IUPAC name, if you go to scientific center, if you have ethanol means each and every country follows the same name. Okay, that is IUPAC name. So in these students, International Union for Pure and Applied Chemistry, International Union of Pure and Applied Chemistry, what it says. So the name of the organic compounds should follow certain rules. Okay. So the first rule is selection of parent chain. Selection of parent chain. Next, numbering of parent chain. Numbering of parent chain. Okay. Next, third one, identifying functional group. Okay. Next, writing the name by prefix followed by word and suffix. Okay, so in that numbering students, so many rules are there in such a way that which one is the functional group we give preference, that should get the minimum number. Okay, next, if two or more substituents are there, they are named according to the lowest sum rule. So while explaining the compounds, while explaining the name of the compounds, I'll apply this all. Okay, so first I'll write compound CH3, CH2, CH2, OH. Okay, so students, OH is the functional group here. Correct? So parent chain we have to select. Select of the parent chain means the longest chain in which the carbon present. Yes, weight chain is there. So 1, 2, 3 carbon atom is there. So we select with the parent chain. Next, numbering of parent chain and identifying the functional group. Here functional group here means, so you can name this compound from here 1, 2, 3 or from here 1, 2, 3. So the naming of the compound takes place in the order such that the functional group should get minimum value. Understand? So preference should be given to this functional group means this should get the carbon atom to which the functional group bonded should get the minimum value. So numbering from right to left is the correct, because from left to right we got 3 here, from right to left we got 1 here. So this is the correct way of numbering. That is 1, 2, 3. For the first, in the first position, this OH group is present. So first one did, second one did, third one. Next, writing the name. Okay. So here prefix, listen. Always, you will write alkane, alkene, and alkyne. The parent chain should be like this only. Either it has to be a single bond, double bond, or triple bond. So in all these, last E is replaced by functional. In both alkane, alkene and alkyne, the last E is replaced by what? Functional group. So first consider the parent chain with the carbon atoms 1, 2, 3 means that is pro. So all are single bond. There is no double bond means that is A and E. So but last E is replaced by what? This functional group, that is OEL. That is propanol. Understand? You may write the position of this compound also like propan 1 all. But it is simply at the first position means no need to write the position. You simply write it as propanol. So consider another one. CH3, CH, double bond, CH, OH. So again here also selection of the parent chain is only, that is 1, 2, 3 carbon atoms is there. Numbering is done from here because this is the functional group. Correct? So parent chain here is what? With the 3 carbon atom is pro. Double bond is there means that is E. But last E is replaced by this functional group that is ol. That is propanol. Understand? Similarly, the same compound if you want to write it for this, then you will get this is the parent chain and this is the functional group. Here triple bond is there. That is pro for triple bond YNE. Last is replaced by OL. So this is propanol. Understand? Similarly, instead of this OH, any other functional groups are there. Similarly, for this compound I write CH3, CH2, CH2, COOH. Okay, here for second compound CH3, CH2, CH1, CH, COH. Here CH3, C, triple bond C, COOH. Same thing follows, students. Here this is propan. This all here OH is there. That's why this is all. Here COOH is there means that is oic acid. Propanoic acid. Here so propene. Last is replaced by oic acid. Understand? Here it is propine. Last is replaced by oic acid. So here all the parent chain remains same. The only the characteristics of the compound is explained by what? This functional group. That is COOH is there. That is oic acid. Here oic acid, here OH is there, that's why it is alcohol. Instead of this, if CHO is there, so then the name of the compound changes to Al. Only the thing is, remember, the functional group changes, the parent chain remains as it is. Understood? So the parent chain follows the same thing. Nothing is here is propane only, here propane, here propane. The thing changes is here only the functional group. That functional group changes the characteristics of the compound. Okay, students. So in that, these two examples are for the functional group which are taken as suffixes. So now I will give example for the functional group which they are taken as prefixes. Consider here Cl, okay, Cl is the functional group here. So numbering is done in the same manner, okay. So but the thing is, here it is taken as prefix, not suffix. So this is taken as what? Chloro, followed by the parent chain. For carbon atom, 3 means pro, all are single bond is A. That is chloropropane. So here also functional group is chloro. 3 carbon atom means that is pro. Double bond here is there means propene. Okay. So here also 3 carbon atoms with the functional group chloro. This is chloro. Propine. So in all these compounds, what you are going to observe? This parent chain remains same in all the compounds. Okay, so pro remains same. Here for single bond Ane is there, for double bond Ane is there, for triple bond Yne is there. But the characteristic of this and this compound is different. Why it is different? Because here Cl is the functional group, here COOH is the functional group. So, as I told you what is functional group, students, it is the smallest part of the organic compound which decides or which gives specific characteristics to the compound. So, this is all about the naming of the compounds. Okay, so by using this, you may answer so many compounds. So I give all two examples for each of the functional groups. Okay. So example for different compounds is take CH3OH, CH3, CH2, CH2, CH2OH. Okay. Next CH3, CH2, Cl, CH3, CH2, CHO, CH3, CH2, CH2OH. For these compounds, write the example. This is an CH3, CH2, and H2. Okay, students. Remember one thing. When you are considering this CHO, COOH, and this ketone, count the number of them already present in this compound. So here, 1, 2, 3 carbon atoms. So consider the carbon atom which is present in the functional group also, because the carbon atom present in the functional group is also involved in the parent exchange. This is 1, 2, 3. So this one is 1, 2, 3. This one is 1, 2, 3, 4. So in these halide carboxylic acid and ketone group, you count the number of carbon atoms which is present in the functional group also. Try to write the name of the compounds, that will give you the accuracy with the nomenclature. Okay. So in the next class I give the name of these compounds. Understand? So the next one is we will discuss about the different reactions which are going to exhibited by this organic compound, especially alkanes, alkenes, and alkynes. Okay. Alkenes and alkynes. Students, here alkane undergo substitution reaction. Okay, so alkene and alkyne undergo addition reaction. So what is the reason for this is, listen, here alkane, I will take simple example, that is methane. For this I will take the simple example, that is ethene and ethyne. Okay. So students, here the function, here they undergo substitution reaction. Why? Because, so listen, carbon is a tetravalent species. It has the capacity to form 4 bonds Here all the bonds are already satisfied. So then in that case what happens? If you want to add any compound, so then what happens? Any one of this hydrogen is replaced by this Br atom. So the product formula is Br plus HBr. So students, this is the 1, 2, 3, 4 means. So already in the first position hydrogen is there. In the product Br is there. So in the first position exchange of the H and Br takes place. Correct? So for the place of this hydrogen, this Br is substituted. That's why this reaction is called as substitution reaction. What is the reason for this substitution reaction? Why this undergoes substitution means because all are single bond, everything is satisfied. There is no need to formation of the extra bonds here. There is no place for the addition of the extra atom here. That's why they undergoes substitution reaction. So as we come to this compound, that is alkene. So here double bond is there. There may be a chance of addition of H2 or Br2. If Br2 is added, say it way. Br2 is added in present of CCl4, carbon tetrachloride as a Br2 is added in presence of CCl4. So here what happens? It forms H, H, double bond, H, H is different. So in the reactant, one double bond changes to single bond and this Br is added. So students, in the reactant only CH2 group is there. In the product side, along with this CH2 Br is also added. So here the addition of extra Br2 molecule takes place. Hence, so these compounds undergoes addition reaction rather than substitution reaction. Similarly here, if you have 2 Br2 in presence of CCl4, then you will get C single bond to C, H, H, Br. Here also 2 double bond is changes to a single bond. So these two are students unsaturated compounds, and this one is saturated. So in the saturated compounds, all the bonds are satisfied. There is no place for the addition of the extra atoms. That's why here substitution takes place. Here in the unsaturated means double bond and triple bond is there. They are not that much stable. So there is a chance of addition of extra molecules to these molecules. Hence they undergoes addition reaction rather than substitution reaction. So these are the reactions which exhibited by the alkanes, alkenes and alkynes. In that, the very important thing is chlorination of methane. The very important thing is what? Chlorination of methane. So student, first CH4 is there. If it is treated with Cl2 in presence of sunlight, then if one hydrogen replaces by the Cl means it forms CH3Cl plus HCl. So then consider this CH3Cl. Again they react with Cl2 in presence of sunlight. Then another hydrogen is replaced here, that is CH3, and right here this is hydrogen. So in the first compound, one hydrogen is replaced by Cl, then becomes CH3Cl. So in the second compound, when again it reacts with Cl2, it becomes CH2Cl2 plus HCl, means another hydrogen is replaced by Cl. So in the third, consider this, that is CH2Cl2. If this undergoes chlorination in presence of sunlight again, another hydrogen is replaced by Cl and form CHCl3 plus HCl. Next, consider the CHCl3. If it undergoes chlorination in presence of sunlight, they form CCl4 plus HCl. So all the hydrogen atoms may have the capacity to be replaced by the other atom. So this is called chlorination of methane. Okay, students. So this all completes the organic chemistry chapter. Okay. The next class we will discuss about the nomenclatures if possible. Otherwise, I will start the next one. Okay.